October 1944. The Hurtgen Forest along the German-Belgian border. Private James Morrison of the 28th Infantry Division crouches behind a shattered oak tree, his M1 Garand clutched tight against his chest. The forest is a nightmare, trees splintered like matchsticks, mud mixed with blood. The constant crack of gunfire echoing through the mist that clings to everything like a cold, wet shroud. Morrison is 22 years old. He's from Kansas, a farm boy who'd never been more than 50 miles from home before the army shipped him to Europe. He's been in combat for 4 months now since the breakout from Normandy, and he's seen things that will haunt him for the rest of his life. But right now, in this moment, he's just trying to understand what he's seeing. His squad has just overrun a German position after 2 hours of brutal fighting. 2 hours of hell. 3 men from his squad are dead. 2 more are wounded badly enough that they're being carried back to the aid station. The survivors are exhausted, shaking with adrenaline, some of them vomiting from the stress and fear. But they've taken the position. They've won this small, bloody piece of the Hurtgen Forest, and now Morrison stands among the captured equipment trying to make sense of it. Scattered across the forest floor are dozens of rifles. Not the semi-automatic weapons he expected from a modern military power. Not even the submachine guns he'd heard the Germans had, but bolt-action rifles, the Carabiner 98K. A design that dated back to 1898, the year Morrison's grandfather was born. Morrison picks one up. It's well-maintained, the woodstock dark with oil and wear. The metal is cold in his hands. He works the bolt, smooth, precise, but maddeningly slow compared to his Garand. The mechanism is simple, elegant even. Pull the bolt handle up, draw it back, push it forward, rotate it down, chamber around. Pull the trigger. Then do it all again. His Garand doesn't require any of that. He can fire 8 rounds as fast as he can pull the trigger. 8 shots in less than 6 seconds if he's in a hurry. This German weapon requires manually cycling a bolt between each shot. 1 shot, work the bolt. Another shot. Work the bolt again. It's like something from a different era, a different war. Why don't these bastards just give up? Morrison mutters to his sergeant, a grizzled veteran named Mackenzie who's been in the army since before Pearl Harbor. We can put out twice their fire rate. Hell, maybe 3 times. It's like they're fighting with museum pieces. Sergeant Mackenzie doesn't answer right away. He's seen too much to make quick judgments about the enemy. He's fought the Germans in North Africa, in Sicily, in Italy. He's learned not to underestimate them, no matter what weapons they carry. He picks up one of the Kar 98Ks, examines it with the eye of someone who understands firearms. "Don't know, kid," Mackenzie finally says. "But I'll tell you something. These rifles killed half our squad today. So maybe they know something we don't." Morrison's question echoes what thousands of American soldiers are thinking across Europe at this very moment. Why are the Germans still using bolt-action rifles when America has equipped every single infantryman with a semi-automatic? It's 1944. This is supposed to be a modern mechanized war. Yet here are the Germans fighting with technology from their grandfather's generation. What Morrison doesn't know, what won't become clear until after the war, through interrogations and analysis and captured documents, is that he's asking the wrong question entirely. To understand why Morrison's question matters, why it reveals something fundamental about warfare and technology, we need to step back 8 years, back to 1936, when the United States Army made a decision that would revolutionize infantry warfare and change the calculus of combat forever. That year, after extensive testing and debate, the U.S. Army adopted the M1 Garand as the standard service rifle for every American soldier. Not just special troops, not just certain elite units, not just officers or marksmen. Every infantryman, from the greenest private to the most seasoned sergeant, would carry this semi-automatic marvel. The decision was controversial at the time. Many old line officers argued that semi-automatic fire would lead to wasted ammunition. Soldiers would spray rounds wildly instead of aiming carefully. The logistics of supplying all that ammunition would be impossible. The rifles would be too complex for average soldiers to maintain. The mechanism would be unreliable under combat conditions, but the Army pushed forward. They saw the future of infantry combat, and it looked like the M1 Garand. This was unprecedented in military history. Britain had their bolt-action Lee Enfield, a fine rifle that had served since 1895. Germany had their Mauser designs, evolved and perfected over decades. The Soviets had their Mosin Nagant, rugged and simple. France had the Liebel and Berthier rifles. Every major military power in the world equipped their infantry with bolt-action rifles that required manual operation between shots. But America was going to do something different. America was going to arm its entire military with a weapon that could fire as fast as you could pull the trigger. It was an audacious gamble, a massive investment of resources and industrial capacity. If it failed, if the rifles proved unreliable, or if the ammunition supply broke down, the entire American infantry would be crippled. The M1 Garand was a masterpiece of engineering, the culmination of decades of firearms development. 9.5 pounds of American steel and walnut, designed by a Canadian-American immigrant named John Garand at the Springfield Armory. Gas-operated, meaning it used the force of the fired cartridge to automatically cycle the action and chamber the next round. Every time you pulled the trigger, the bullet went down range. The expanding gases drove a piston. The piston unlocked and cycled the bolt, ejected the empty case, chambered a new round, and locked the bolt, all in a fraction of a second. All automatically. The shooter just had to aim and fire. It held 8 rounds in an en-bloc clip that slid into the rifle from the top. The 30-06 Springfield cartridge it fired was powerful enough to drop a man at 500 yards, punch through light cover, and deliver devastating energy on target. And it was accurate in the hands of a trained marksman. The Garand could hit man-sized targets consistently at 400, 500, even 600 yards. The rifle went into full production in 1940. By the time America entered World War II in December 1941, hundreds of thousands had been produced. By D-Day in June 1944, virtually every American infantryman in Europe carried one. Total production during the war would exceed 4 million rifles. General George S. Patton, never one for understatement, called it the greatest battle implement ever devised. And in many ways he was right. When American forces landed on the beaches of Normandy on June 6, 1944, they carried a firepower advantage that no other army in history had ever possessed at the individual level. A single American infantry squad could put out more aimed fire than a comparable German, Japanese, or even British unit could hope to match. The statistics were staggering. In the time it took a German soldier to fire 5 aimed shots with his Kar 98K, working that bolt between each round, an American soldier could empty his entire 8-round clip and be reaching for another. In close-quarters combat, in the chaos of urban warfare, in the desperate scramble of assault and counterattack, this advantage was overwhelming. American after-action reports from France and Belgium consistently noted how German positions would collapse under the sheer volume of fire American infantry could deliver. Villages that might have held out for days fell in hours. Defensive positions that seemed impregnable crumbled when hit with sustained Garand fire. The psychological impact alone was significant. German soldiers reported feeling outgunned, overwhelmed by the volume of incoming rounds. Training manuals emphasized this advantage. American soldiers were taught to use their semi-automatic capability aggressively, suppress the enemy, pin them down, pour fire into their positions. The doctrine was built around the idea that volume of fire, sustained, accurate, overwhelming fire, would win engagements, and often it did. In the hedgerows of Normandy, American squads could advance under covering fire from their own Garands in ways that bolt-action equipped units couldn't manage. In the towns and cities of France and Germany, the ability to deliver rapid fire while clearing rooms and buildings was a decisive advantage. In the Pacific, where American forces island-hopped across vast distances to close with a fanatical enemy, the Garand saved countless lives. But here's where the story gets interesting. Because while American soldiers were celebrating their technological superiority, while training manuals praised the Garand, while generals touted the advantage it gave American forces, German soldiers weren't scrambling to copy the American design. They weren't desperately trying to produce more semi-automatic rifles. They weren't abandoning their obsolete bolt actions in favor of captured American weapons. They were, in fact, quite content with their carabiner 98Ks. Now let's be absolutely clear about something. The Germans weren't stupid. They weren't technologically backward. They weren't clinging to outdated weapons out of ignorance or inability to innovate. This was a nation that had developed the Tiger tank, one of the most formidable armored vehicles of the war. They'd created the V-2 rocket, the world's first long-range ballistic missile. They'd built the Me-262, the first operational jet fighter. They understood firearms technology better than almost anyone in the world. And they had, in fact, developed their own semi-automatic rifles. The story of German semi-automatic rifle development is fascinating in itself. It starts in the 1930s when the Wehrmacht began exploring self-loading rifle designs. They looked at the Soviet Tokarev SVT-40. They studied captured Polish rifles. They examined American designs. They understood the potential advantage of semi-automatic fire. The first result was the Gewehr 41, which appeared in two variants in 1941, one from Mauser, one from Walter. Both were complicated designs that used a gas trap system at the muzzle, rather than a gas port in the barrel. The idea was to avoid drilling a hole in the barrel, which German engineers feared would reduce accuracy. The result was rifles that were heavy, complex, and prone to malfunction. Combat reports from the Eastern Front were damning. The G41 was unreliable in the extreme cold of the Russian winter. Mud and dirt fouled the gas trap system. The rifles were difficult to maintain in field conditions. Soldiers reported that their G41s would work for a while, then fail at critical moments. Many German soldiers simply discarded them and picked up captured Soviet rifles or went back to the trusty Kar 98K. But the Germans learned from these failures. In 1943, they introduced the Gewehr 43, a completely redesigned weapon. This time they swallowed their pride and copied the gas port system from the Soviet SVT-40. The result was much better. The G43 was lighter than the G41, more reliable and easier to maintain. It used a detachable 10-round magazine rather than the Garand's fixed clip system, which meant it could be topped off without ejecting unfired rounds. It was, by any objective measure, a good rifle. Some experts would argue it was better than the Garand in certain respects. Lighter, easier to reload with a cleaner sight picture. The G43 saw service on all fronts. Soldiers who received them generally liked them. After-action reports were positive. The rifle worked, so why didn't the Germans produce millions of them? Why did they continue cranking out carabiner 98Ks by the millions, approximately 14 million over the course of the war, while producing only about 425,000 semi-automatic rifles total? American intelligence analysts had theories. The most common was that German industry simply couldn't handle the complexity of large-scale semi-automatic production. Maybe they lacked the machine tools or the skilled workers. Maybe the bombing campaign had disrupted their manufacturing capability. Maybe it was a sign that Germany was losing the industrial war, unable to modernize, their infantry, while America surged ahead with superior production capacity. Some analysts theorized that the Germans were running low on strategic materials, the high-grade steel needed for semi-automatic mechanisms, the chemical treatments required for proper heat treatment. Others suggested that the loss of occupied territories had cut off supplies of walnut for rifle stocks, or that transportation disruptions made it impossible to distribute new rifles to frontline units. But here's what those analysts missed. What wouldn't become clear until extensive post-war interrogations and document reviews. The Germans didn't want to replace the Kar 98K en masse. They weren't clinging to it out of desperation or industrial inadequacy. They were making a calculated decision based on a fundamentally different understanding of how infantry combat actually worked. You see, when the U.S. Army designed their infantry doctrine around the M1 Garand, they built a system where the rifle was the primary weapon of the infantry squad. 8 men, 8 Garands delivering overwhelming firepower. The Browning automatic rifle provided some additional automatic fire capability, but fundamentally, the American squad was built around individual riflemen as the main source of combat power. The German squad was built around something else entirely, the machine gun. Specifically, the Maschinengewehr 42, the MG42. If you've ever watched a World War II movie and heard that distinctive sound, that ripping, tearing noise like heavy fabric being shredded at impossible speed, that's the MG42. The Americans called it Hitler's buzzsaw. The Germans called it Hitler's zipper, or simply the bone saw. Soldiers who faced it called it terrifying. The MG42 fired 1,200 rounds per minute in its standard configuration. That's 20 rounds per second. Let that sink in. In the time it takes to say one Mississippi, 27 92mm bullets were flying downrange. The cyclic rate was so high that you couldn't hear individual shots, it was just one continuous roar. The sound alone was psychologically devastating. American soldiers reported freezing in terror the first time they heard it, their brains unable to process that this was small arms fire and not some kind of artillery or bomber attack. But it wasn't just psychological. The MG42 was phenomenally effective. Its high rate of fire meant that even brief bursts put multiple rounds on target. It could suppress entire squads, pin down platoons, and turn any open ground into a kill zone. German machine gun teams were trained to fire in short, precise bursts, 3 to 5 rounds at a time, conserving ammunition while maintaining suppressive fire. But when they opened up with sustained fire, the effect was apocalyptic. In German infantry doctrine, the MG42 was the squad's killing weapon. Everything else, every rifleman, every piece of equipment, every tactical decision, existed to support that machine gun. The squad leader's primary job was to position the machine gun effectively. The riflemen weren't there to be the primary source of firepower. They were there to protect the machine gun team, to eliminate specific threats at range, to conserve ammunition, and to provide supporting fires that allowed the machine gun to do its work. And for that role, the Carabiner 98K was absolutely perfect. Let's get deep into the technical details because this is where the story really gets interesting. This is where we understand that the choice to keep the Kar 98K wasn't about backwardness, it was about optimization. For a specific purpose, the Kar 98K weighed approximately 8.6 pounds unloaded. The M1 Garand weighed 9.5 pounds. Not a huge difference, less than a pound. But over a long march carrying full kit, that pound matters. German soldiers in 1944 were often marching 20, 30, sometimes 40 kilometers a day as they repositioned to meet Allied advances. Every ounce of weight they could save was an ounce they could dedicate to ammunition, rations, or equipment. But weight wasn't the main factor. The real differences were more subtle. The Kar 98K was 43.6 inches long overall with a barrel length of 23.6 inches. The Garand was 43.5 inches overall with a 24-inch barrel, nearly identical dimensions. But the way that length was distributed, the way the balance point fell, the way the rifle handled, the German rifle had certain advantages. First, accuracy. The Kar 98K's longer barrel and more rigid action gave it an edge in pure accuracy, especially at extended ranges. This wasn't a massive advantage. Both rifles were plenty accurate for military purposes. But in testing, the Kar 98K showed slightly tighter groups at 400+ yards. The simpler bolt-action mechanism had fewer moving parts, less vibration during firing, and a more consistent lockup. The Garand's gas-operated system, for all its sophistication, introduced variables that could affect accuracy. Second, the cartridge. The 7.92 Gus hit 50mm Mauser round that the Kar 98K fired was more powerful than the American 30-06 Springfield. The Mauser round delivered about 3,700 joules of muzzle energy, compared to the 30-06's 3,600 joules. Not a huge difference in raw power, but the Mauser had better long-range ballistics. It retained velocity and energy better over distance. At 600 meters, the German round was hitting significantly harder than the American round. This mattered because of how German soldiers were trained. German marksmanship training emphasized long-range precision shooting. German soldiers were expected to engage targets at 400 to 600 meters as a matter of routine. Their rifle sights were calibrated out to 2,000 meters. Absurd for actual combat, but it reflected their training philosophy. A German infantryman was trained to find a stable position, range his target, adjust his sights, and take a carefully aimed shot. American training was different. American soldiers were taught to engage at 300 meters and under. The emphasis was on quick target acquisition and rapid follow-up shots. The Garand's semi-automatic capability supported this doctrine perfectly, but it also meant that American soldiers often weren't taking advantage of their rifles' full-range potential. They were fighting at distances where the Kar 98K's long-range advantages didn't matter, but where the Garand's rate of fire did. But here's where it gets really interesting: reliability and maintenance. The M1 Garand was a gas-operated semi-automatic rifle. When you fired it, a portion of the hot, high-pressure gases from the burning powder were diverted through a port drilled in the barrel, about halfway down its length. Those gases entered a gas cylinder beneath the barrel, where they drove a piston backward. The piston was connected to an operating rod, which unlocked the rotating bolt, drove it backward to extract and eject the empty case, then allowed a spring to push everything forward again, stripping a new round from the clip and chambering it. The bolt rotated back into battery, locked, and the rifle was ready to fire again, all in perhaps a quarter of a second. Brilliant engineering, sophisticated, complex, and therein lay the problem. Every part of that system had to work perfectly for the rifle to function. The gas port had to remain clear. The gas cylinder had to be free of fouling. The piston had to move smoothly. The operating rod had to be straight. The bolt lugs had to be properly maintained. The clip had to feed smoothly. Any failure in this complex chain, and your semi-automatic rifle became a cumbersome single-shot weapon. In the deserts of North Africa, the Garand could be finicky. Sand got into the gas system and suddenly your sophisticated rifle was jammed. Soldiers learned to keep their actions closed whenever possible, to oil their rifles frequently, to avoid exposing the mechanism to blowing sand. But in a combat environment, that wasn't always possible. In the freezing winters of Northern Europe and the Eastern Front, the Garand's gas system could freeze. The oil in the mechanism could become too viscous to function properly. Moisture could freeze in the gas cylinder, blocking the gas flow. The operating spring could lose tension in extreme cold. Soldiers learned to use lighter oil, or no oil at all, relying on just the bare metal. They learned to keep their rifles inside their coats when possible, using body heat to keep the mechanisms from freezing. But again, in combat this wasn't always an option. The Kar 98K, it had a bolt. You worked it with your hand. That was it. There was no gas system to clog with sand or freeze with moisture. There was no complex sequence of mechanical operations that had to work perfectly. The Kar 98K's action had been refined and simplified over nearly 50 years of use. The bolt had two massive lugs at the front that locked directly into the receiver. You lifted the bolt handle, rotated those lugs out of their recesses, pulled the bolt back to extract and eject, pushed it forward to chamber a new round, and rotated it down to lock. Simple, intuitive, robust. German soldiers on the Eastern Front told stories that sound almost mythical but were verified by multiple sources. Rifles frozen into solid blocks of ice during the brutal Russian winter. Soldiers would chip away the ice, work the bolt a few times to make sure it moved freely, and go right back to fighting. Rifles buried in mud during the spring Rasputitsa, the season of mud when Russian roads became impassable swamps. Soldiers would dig them out, wipe off the worst of the mud, and keep fighting. Rifles that hadn't been properly cleaned in weeks or months because the unit was in constant combat. They kept working. American soldiers with Garands couldn't afford that level of neglect. They had to keep their rifles clean and properly maintained or risk malfunctions. Field maintenance manuals for the Garand were detailed and specific. There were proper procedures for cleaning the gas system, for checking the operating rod for straightness, for ensuring proper clip feeding. If something went wrong with your Garand's gas system in the field, you often needed an armorer, a trained specialist with proper tools to fix it. If something went wrong with your Kar 98K, you probably just needed a new rifle, because there wasn't much that could go wrong. The bolt broke? Replace it. Any bolt from any Kar 98K would work. The firing pin broke? Replace it. A 5-minute job with a screwdriver. The stock cracked? Keep using it or swap it out when you got a chance. The sights got knocked off? Use Kentucky windage and keep fighting. This simplicity extended to training. A German soldier could be taught to completely disassemble and reassemble a Kar 98K in an hour or two. Every part of the rifle was accessible. Every component was obvious in its function. The rifle could be field stripped with no tools beyond the soldier's hands, and detail stripped with just a screwdriver and a punch. The Garand required significantly more expertise. The gas system wasn't meant to be disassembled in the field. The trigger group was complex. The clip feeding system had multiple springs and followers that had to be properly assembled. A soldier could learn basic field maintenance, but anything beyond that required specialized training. By late 1944, Germany was desperately short of experienced soldiers. They were drafting 16-year-old boys from the Hitler Youth and 50-year-old men from the Volkssturm Home Guard. These soldiers got perhaps a few weeks of training before being thrown into combat. Teaching them to effectively use a bolt-action rifle was straightforward. Teaching them to properly maintain a complex semi-automatic would have taken training time they simply didn't have. And then there was the ammunition issue, arguably the most tactically significant difference between the two. Weapons. The Kar 98K fed from a 5-round stripper clip. The soldier would open the bolt, place the stripper clip in guides on top of the receiver, use his thumb to push all 5 rounds down into the internal magazine, then discard the clip. The magazine held 5 rounds total, but here's the key: you could top it off at any time. 3 rounds left in the rifle? Slide in 2 more rounds from a partial clip. 1 round left? Add 4 more. The magazine could be loaded 1 round at a time if necessary. German soldiers routinely kept their rifles topped off during lulls in combat. The Garand used an en-bloc clip, the entire clip loaded into the rifle from the top, becoming part of the feeding mechanism. 8 rounds, and when the last round was fired, the clip ejected automatically with a distinctive metallic ping. You couldn't top off the Garand without ejecting the entire clip, wasting any unfired rounds. In practice, soldiers learned to fire off any remaining rounds and reload, or to manually eject the clip when they had a chance. But this was time-consuming and wasted ammunition. That ping, that distinctive ejection sound, became famous, or infamous depending on which side of the line you were on. American soldiers initially thought the ping was just a quirk of the rifle, maybe even a useful feature that told you when you were empty. But German soldiers quickly learned to listen for it. In the close-quarters combat of urban warfare or dense forest, sound carried. So how did all these technical differences, the weight, the accuracy, the reliability, the ammunition systems, play out in actual combat? To understand that, we need to go back to the battlefields of 1944 and early 1945, where American and German forces clashed repeatedly in a grinding war of attrition. The Hurtgen Forest, where we started this story, is the perfect example. The battle for the Hurtgen lasted from September 19, 1944, to February 10, 1945, nearly 5 months of continuous combat. It was one of the longest and bloodiest battles the U.S. Army fought in Europe, and one of the most controversial. The forest itself was about 50 square miles of dense evergreen woodland on the Belgian-German border, with terrain that favored the defender in every possible way. The trees were so thick that visibility was often reduced to 30 meters or less. Artillery airbursts, shells designed to explode above ground to spray shrapnel downward, often detonated in the forest canopy instead. The result was even more devastating. Huge splinters of wood, some as large as spears, showering down on anyone below. Soldiers described it as being in a sawmill during a catastrophic accident. Men were killed or wounded by wooden shrapnel as much as by metal fragments. The forest floor was a nightmare of fallen logs, underbrush, and steep ravines. Vehicles couldn't maneuver off the few roads. Visibility was so limited that command and control broke down. Officers couldn't see their own squads, let alone coordinate company or battalion-level movements. Combat often devolved into small unit actions, squad against squad, sometimes individual soldiers fighting private wars in the green darkness. This was the environment where American firepower superiority should have dominated. Close-quarters combat, reduced visibility, sudden violent encounters at ranges of 50 meters or less. The perfect environment for the Garand's rapid-fire capability to shine. And yet, the Germans held. American squads would advance through the forest, moving carefully from cover to cover, their Garands at the ready. The doctrine emphasized aggressive movement supported by fire. Half the squad would advance while the other half provided covering fire. Then they'd leapfrog forward. It was textbook infantry tactics, and it should have worked. When they encountered a German position, and they encountered them constantly, because the Germans had had months to prepare defenses in depth, the American squads would do what they'd been trained to do. They'd open fire. 8 Garands would light up the suspected enemy position, pouring lead into the trees and undergrowth. Dozens of rounds in seconds, the rapid crack of semi-automatic fire. The Americans were certain they had suppressed the position, maybe killed everyone there. The volume of fire was overwhelming. Then they'd advance, moving forward to secure the position and continue the attack, and that's when the MG-42 would open up. The sound was distinctive and terrifying, a high-pitched roar like ripping canvas, so fast that individual shots blended into a continuous noise. 20 rounds per second hammering into the advancing Americans. Men would drop, killed or wounded, before they could react. The survivors would hit the ground, scrambling for whatever cover they could find. pinned down by the sheer volume of fire. What had happened? The German squad hadn't been trying to match the American fire rate. That would have been pointless. 8 bolt-action rifles couldn't hope to match 8 Garands for volume of fire. Instead, the German riflemen had been concealed, holding their fire, protecting the machine gun position. When the Americans suppressed the area with rifle fire, the Germans simply stayed down and waited it out. The rifle fire was dangerous but not decisive. But when the Americans exposed themselves by advancing, that's when the MG-42's crew went to work. The machine gun had been positioned to cover the most likely avenue of approach. The gunner had waited patiently for targets to present themselves. And when they did, he pressed the trigger and held it, sweeping the gun across the kill zone in short, precise bursts. The German riflemen would then engage specific targets, Americans trying to flank the machine gun, squad leaders trying to organize a response, anyone with a radio or looking like they were in charge. The Kar-98K's accuracy at range was perfect for this precision shooting. The riflemen weren't trying to suppress the Americans with volume of fire. They were killing specific threats with aimed shots. Lieutenant Paul Bosch, who fought through the Hurtgen with the 3rd Battalion, 413th Infantry Regiment, described the experience in his memoir, Road to Hurtgen Forest in Hell. We'd pour fire into a position, certain we'd suppressed it, and the moment we advanced, that damn machine gun would open up again. It was like fighting ghosts. You couldn't see them, couldn't pin them down, couldn't silence them. Their riflemen didn't waste ammunition trying to outshoot us. They waited for clear shots and protected their machine gun like it was the Holy Grail. And I suppose it was, because that machine gun was what killed us, not their rifles. That buzzsaw. Another veteran, Ernest Hemingway, yes, that Ernest Hemingway who was in the Hurtgen as a war correspondent, wrote about the experience. The forest fought for the Germans. The trees, the mud, the cold, the darkness, it all favored defense. And they'd built their defense around those machine guns. Everything else was in service to those guns. Smart, ruthless, effective. The casualty figures from the Hurtgen tell the story better than any description. The U.S. 28th Infantry Division entered the forest with about 12,000 men. After fighting there for 2 weeks in November 1944, they had suffered 6,184 casualties, more than half their strength. The division was pulled out of the line, completely combat ineffective. The 4th Infantry Division, which had landed on Utah Beach on D-Day and fought across France, entered the Hurtgen in November. They suffered 7,000 casualties in the forest. The division's casualty rate exceeded 100%. They took more casualties than their original strength, meaning replacement soldiers were being killed or wounded as fast as they arrived. The 1st Infantry Division, the famous Big Red One, fought in the Hurtgen and suffered over 4,000 casualties. The 8th Infantry Division, nearly 5,000 casualties. In total, American forces suffered approximately 33,000 casualties in the Hurtgen forest over 5 months of fighting. Some estimates go as high as 55,000, when including non-combat casualties like trench foot, frostbite, and combat fatigue. German casualties were significant too. The Wehrmacht and SS units defending the forest suffered roughly 28,000 casualties. But they were on the defense in prepared positions, and they made the Americans pay dearly for every meter of ground. And a significant portion of those American casualties came from German machine gun fire, supported by riflemen with obsolete bolt-action rifles. But the pattern wasn't limited to the Hurtgen. It repeated across Europe wherever American and German forces met. In Normandy's bocage country, the hedgerow terrain, of small fields separated by thick earth embankments, topped with dense vegetation, German defensive tactics followed the same pattern. Machine gun teams would position themselves with interlocking fields of fire covering the gaps between hedgerows. The riflemen would engage at range, forcing American infantry to keep their heads down, while the machine guns waited for targets to expose themselves. American commanders tried various solutions. Artillery preparation before attacks, but in the bocage in the forest, artillery wasn't as effective. The earth embankments and thick trees absorbed much of the blast. Armor support, but tanks were vulnerable in close terrain, easy prey for German Panzerfaust teams. Air support, but in the Hurtgen the forest canopy was so thick that pilots couldn't see targets on the ground. What consistently worked was overwhelming the German positions with combined arms, infantry, armor, artillery, engineers all working together. But even then the cost was high. The German defensive system, built around the MG-42 and supported by Kar-98K armed riflemen, proved remarkably resistant to American firepower advantages. In the urban combat of Aachen, Germany, the first major German city captured by American forces, the same tactics applied but intensified by the urban environment. German machine gun teams would position themselves on upper floors or in basements with fields of fire, covering streets and squares. The riflemen would cover windows and doors, engaging American infantry trying to maneuver between buildings. Staff Sergeant Mac Morris, a combat correspondent with the 26th Infantry Regiment during the Battle of Aachen in October 1944, wrote, "Their tactics were simple but effective. They'd let us advance into the street, then the machine gun would open up from some window or basement. While we were pinned down, their riflemen would engage from other buildings. We couldn't advance, couldn't retreat without taking casualties. We'd have to bring up tanks or tank destroyers to blast the machine gun position, then clear the surrounding buildings room by room."